Okay, so last class we finished first normal form, and now we can move on to second normal form. And before second normal form, I want to introduce more definition here. That is full functional dependency. So what is full functional dependency? For functional dependency y to z, when we remove any attribute from y, means functional dependency does not hold anymore. So for example, SSN P number to hours, right? So if we remove SSN, then P number to hours, that's what we're left, right? So this one means this functional dependency from P number to hours does not hold anymore. This is a false. And if we remove this one, SSN to hours, then SN to hours is not true. So again, this functional dependency does not hold anymore. That means I need SSN and P number together, right? So in this case, this is called full functional dependency. So full functional dependency, if we go back to the minimum cover definition, remember the left-hand set only include the necessary information. This is similar. So any full functional dependency, whatever on the left, everything here is, necessary. You cannot remove anything. That's the full functional dependency. And what is a partial dependency? So if something is not a full functional dependency, then it is a partial dependency. So they are just opposite. So for example, this functional dependency is partial dependency because I can remove this one, and whatever left, that's SSN to ename, still true, right? So that means this whole thing is a partial dependency, means we have unnecessary information on the left-hand side. That's partial dependency definition. So again, any functional dependency, either that's fully functional dependency or partial dependency. So if it's not full, then partial. If it's not partial, then be full. Okay, before I do second normal form, one more definition. Okay, so prime attribute. Okay, so what is attribute? What is a prime attribute? If an attribute that's a part of any candidate key. And so when we see the candidate key here, means if we have 1, 2, 3, 3 keys, then every single one is a candidate key, right? So we introduce candidate key here. So any the keys we have, they all candidate key. So in other words, when we consider prime attribute here, we consider all the keys. So the definition based on this prime attribute based on all the candidate key. So if we consider all the candidate key, multiple candidate keys, this is called a general definition with second normal form. Okay, and so you have to use the definition we used in class to answer questions in the exam. There are other ways to define second normal form and third normal form. And if you use any other way to do, answer the question, you just get a 0 for the question. And so for the book, you may see one part is based on primary key only for second normal form. For example, we do not want to use that. We want to use the general definition, means we consider all the candidate key, not only primary key. Okay, so what we need to do here is, I'm going to show you an example of prime attribute. So prime attribute as defined, if it is part of any candidate key and also part of, it's not necessarily, cover all the things in the candidate key. Right, so let me give you a relation R here. Say I have the following attribute here, okay? And for this one, I want to, I can give you the keys. Okay? So in 134 class, when we check normal forms, and when we need the keys, I'm going to give this to you. So that's something given in the question. Okay. And when you go to 174, we'll learn how to using algorithm to produce keys. But not here. So here, so that's why I gave this to you. So say I have two keys. One is ABC, the second key is D itself. Okay, it's two keys. Okay, one is the composite, the other is the single attribute one. And let's see what is the prime attribute. So it's actually a part of any candidate key. So let's see which one is the prime in my example. So in this case, A is part of this key, right? And satisfy definition, so A is prime. And B is a part of this key, so B is also prime. And C is a part of this key, so C is also prime. And D is a part of this, they're actually the same, so D is also prime. And E is not a part of any key, so E is not a prime attribute. So if attribute is not a prime, then it's called a non-prime attribute. Okay. So this is similar for any attribute given. Either it is a prime, if it's not a prime, it's non-prime. So either it's prime or non-prime, only one of them. Okay, so non-prime attribute means if an attribute is not a prime, that also means an attribute is not part of any key. So E is not a part of this key, and E is also not part of this key. So that's why this non-prime attribute is E in this example. Okay, hope this is clear, and you can quickly take a look at the example, because otherwise we'll have issue about second normal form. It's all based on this. Okay. So let's see the second normal form definition. This one talk about every non-prime attribute A. Okay, so this case I only have one, but we have other cases like many of them. Say I have three non-prime. For example, non-prime, I have attribute A1, A2, A3, right? So possible. So every non-prime must be fully functionally dependent. And what is a full functional dependency? We just finished that, right? Every non-prime is fully functionally dependent on every key of R. So now there's another array, and that's key. So for key, right, say for example, I have K1, I have K2. So this means every non-prime must be fully functionally dependent on every key. So you can see A must be fully functionally dependent on K1. A must be fully functional dependent on K2, A1, and A2. A2 must be fully functional dependent on K1. A2 must be fully functional dependent on K2. A3 must be fully dependent on K1 and also fully on K2, right? So in this case, array and array here, if this is true, right? So like what I did here, so every non-prime fully depends on key, then we can say this is in second normal form. But if any of them is not true, say for example, if I know A3 is not fully dependent on K2, then I can say this is not, then this is not in second normal form. Okay, so this is the basic logic things you should know, right? So if we say yes, then that must be satisfy every non-prime fully depend on every key. But if you say no, you just need to find one violation. That's sufficient to say no, it's not in second normal form. Okay. I hope this is clear on the definition. And we're going to move to an example to show. Oh God. So basically, you need to understand this combination, right? This kind of non-prime and key, and we'll understand how to do this. And so let's using this second normal form example. And in this example, I have two keys. One is the property ID, one is county name and last number together, to combine of two of them. And remember, when we have a second normal form, we must have the functional dependency, right? So that must be given. And as I said, I always give you the keys, and now you have the functional dependency showing here. Remember the left-hand set is something without arrow. If you see things without arrow, like property ID and functional dependency number one, means this is left-hand set. And the things on the right-hand side is the one how arrow point to it. So first functional dependency is left-hand side is property ID. It determines county name and loss number and the area, price, and tax rate. The second functional dependency talk about if I know the county name and I know the lots number of a property, right? Like a house has lots number. If I have both, then I know what property. So there's only one property related to that with the property ID. And I know which area and the price of the property, and also what is the tax rate of it. And the last functional dependency talk about if I know the county name, right? Say Sacramento County, then I know the tax rate. So this one tell you, no matter you in lots 1 or lots 2, or what is your property ID, as long as you in Sacramento County, then you have the same tax rate. So that's what this functional dependency about. So we are going to, sometimes you see I use like a ABCD here. So the semantic actually captured in the functional dependency already. So the reason I use this, like make this like kind of make people understand things better when you think about like the house you have and the tax you pay, the things like that, right? So hopefully it can be easier to understand what's going on. Okay, and let's see. So in order to check second normal form, right? So this will be the type of question that when people give you a design, I give you this design with the following functional dependency, and give you the key and ask you, is this in second normal form or not, right? So the question is it second normal form or not, and why? Okay, remember you need to tell me why, otherwise you just say yes or no, you don't get the points. And you have to follow this definition that we cover in the class to answer the question in order to get points. Okay, so let's see. In order to be second normal form, we need to answer this question, right? What are the non-prime and what are the keys? This part already answered. The key is given, right? So you already know the key. Then the next thing we need to know is, so let me write this down. So first thing I want to do is, I want to find out all the non-prime attributes, right? Okay, so what are the non-prime? And we can see this is a part of the first key. So this is a prime. County name is a part of this key, so this is a prime. Loss number is part of this key, so this is a prime. And the area, price, and tax rate, they are like this one is not part of this key, this is not part of that, so this is a non-prime. Similarly, price is not part of this, this is not part of this, so price and tax rate, they are non-prime. So we know the keys already, right? And we know the non-prime. The next thing we need to do is this one. So we need to know every non-prime fully depend on, okay, fully, we want to see every non-prime is fully depend on every key or not. And what we need to see is if we can find the relation, then we do not need to continue because we can just say not in second normal form, give the reason. But if we don't find the relation, we need to keep going until we finish the last one. Then we can say, yes, this is in second normal form. And let's see this case. So I already have the non-prime. So my first question is my first non-prime attribute, right? My non-prime attribute area is this one. Maybe using the other side, so I have a little bit more space. So my first question is, right? So this is pretty much like what we did here, right? For A1 depends on K1, K2. So this, I want to see the fully dependent or not. And now I found something interesting, right? So remember when we talk about full functional dependency, okay, before I answer this question, I found something interesting. When we talk about full functional dependency, we'll go back, right? Full functional dependency means we can remove nothing from left, right? So what happens if my left side only have one attribute? That's actually the case we have, right? The case we have is from property ID number to something, right? And my left-hand side only have one attribute. So from the definition, we can see if left-hand side only have one attribute, then this is guaranteed to be full functional dependency. Okay, so remember this rule. If we have only one attribute on left, right? So if only one attribute on the left-hand side, then it is full functional dependency. So if we go back to this, right? So this one, only one attribute, like the first functional dependency here, right? Let's see. Only one attribute on the left. There's nothing you can remove. You have to have at least one on the left. So that's why this is always a full functional dependency. So then this question is yes, right? Non-prime attributes is fully function dependent on first key. Not only that, we can also see price and tax rate. That's the same situation, just because the left-hand side only have one attribute. So they are always three of them. They are the same case. They all fully function dependent on this particular key, right? So let me write this down. Okay, so this is true, right? So it's save some efforts. We don't need to worry about the functional dependency if left-hand set has one attribute, always fully functional dependent on that. Okay, I need to get rid of this. Okay, all right, I guess I can get rid of this. So the next thing I want to do is, should I get rid of all of them? Okay. So this means actually, if we go back to this one, I know the non-prime A1, A2, A3, they all fully depend on one of the key. Now I just need to check with the second key. That's all I need to do. Okay, so what I need to do is I take, you don't have to do area first and price and tax free. You can do any of them firstly. So I want to see. I want to see prime non-prime attribute. Is this one fully functionally dependent on key? The second key is this one, right? So that's something we need to check because this one has two attributes. Right, this is our question. Now we'll see, in order to answer this question, basically this question can be alternatively rewrite like this, right? So I write down this question is because this one said every, so I pick one, fully depend on whether true or not, right? So this question can be alternatively analyzed as county name, lot number, right? And to this, I want to, this same question can be rewrite as, is this particular one a full functional dependency? So if this one's difficult for you to understand, we can rewrite it like this. And so when we see this is relatively easy to analyze because we talk about full and partial, means we can try to see those attributes. Can we remove them or not, right? So can we remove anything or not? Then let's see the two things we can use. One is the given set of functional dependency. The other is the inference rules. And let's see the given one. Here, this is the one closely related to that, right? This is left and this is right. And we have two more functional dependency. But from what I can see here, I cannot remove county name. Okay, so in other words, from the three functional dependency we have, if we have no county name, just loss number to area, this is not true. From the functional dependency and the inference rules, I cannot produce the result of loss number to area. Same thing, I cannot produce the result for county name determine area. We don't know that. So that's why I need both county name and loss number together to determine errors. So that's why this is full functional dependency. And very soon, you will see another case that is not, and you can compare and to see why this is yes, this is no. But in this case, yes, this is a full functional dependency. So far, we do not have any violation, right? So here, so no violation here right now. Okay, and then I know second normal form is actually the hardest one to do the checking compared to like a third normal form, both normal form. They are relatively easy. Okay, so there's no violation so far, and then we need to move on to the next attribute, right? And the next attribute, we are actually doing the same thing. Okay, so I'm going to remove this one, and now I'm going to change this to price. Okay, so in the exam, you are not going to do this. You are going to write down a brand new one. Otherwise, I don't see it. The reason I do this because you watch, you can watch me doing this. You can see the process. But when you do things in the exam, I cannot watch what you did, right? I can only see what appeared in your submission. Okay, so we have. So I'm going to ask the price, the second one, and I'm going to ask, is the price fully functionally dependent on the second key, counting name, lots number, or not? And another way to ask the same question is here. Is this is counting name, lots number to price a full functional dependency or not? And let's see things related to them. Counting name, lots number to price is here, right? And if I remove counting name from lots number to price, based on the existing functional dependency and also based on the inference rules, I don't think that's right. So no matter you remove counting name or you remove lots number, the other attribute cannot determine price. So we need a combination for counting name, lots number together to determine price. In other words, this is a full functional dependency. So the answer is yes. So far there's no violation. Okay, the last one is tax rate. So let me write down here so you can do some comparison. So far, you see there's no violation, you cannot say no, right? But you also cannot say yes because we haven't finished all the possible combination yet, right? So we have the last one. I need to check tax rate is fully dependent on the second key or not. We already know this is fully dependent on first key, but it's not the second one. That's the one we try to see, right? So we ask the same question. So in the exam, you don't have to write down both. Whichever easier for you to understand, you can put that one in. So either this one or that. Of course, you can put both if you want, but you don't have to. I found that some students understand this, some feel this is easy way for them to understand, some feel this is easy way. So you can pick whatever you want. Right, so that's the question. And the same thing you can rewrite like this. And then let's see the functional dependency actually related to this, and you'll be able to see. So I have I have county name, loss number to text read. And I have this from property ID to text read. Actually, it doesn't help me much. But this one is interesting. I have county name to text read. So let me write down both, and immediately you will see the things behind. I run out of space. Maybe I'll just using red color so you be able to see. Okay. And another one is a county name to text read. All right, very interesting. So combine, so they are all coming. This is 2, right? And this is 3. So from that, you can see I don't need this at all, right? I do not need this loss number. I can get rid of this. So county name to text read is there already. So this is, you don't even need the inference to help you directly. You can see this functional dependency is partial. This is not a full functional dependency because you can remove something. And remember the definition for partial. Right? If you can remove something, then that's partial. Okay, so this one tell you this particular dependency is partial, it's not a full functional dependency. So for this particular question, what is your answer? The answer is no, right? And so in other words, you found out a non-prime attribute is not a fully functional dependent on a key, and that's a violation, right? So as a result, you can say this particular one, this particular given one is not actually here. So this is a relation name. This relation name. So we know this is not second normal form. So let me write down this conclusion here. Actually, let's compare this one with this one, right? So difference between them is this one has one functional dependency actually come back to this to tell you, I don't need the loss number. County name itself enough. When I know the county, I don't need to know the loss number. I know how much tax I need to pay, right? Okay, so now I can get rid of this. So let me write down the conclusion here. And if you say yes, remember you need to give me all the combinations, show the steps, best steps, no violation. And since this is no, once you can find out one problem, then that's sufficient. So my final answer. So your final answer here. So you can see loss. This is L. Okay, loss. This is a relation name is not in second normal form because non-prime attribute text rate is okay. Okay, so for the no case, this is the case of no, right? the important thing is I want to see the reason, right? So the why part, right? So why this is not second normal form? You need to tell me the relation, right? So first of all, you told me this is not in second normal form, and you tell me the reason. You don't have to do this, and that's good enough. And this is a new sentence. So non-prime attribute tax rate is not fully function dependent on key. Cannot use abbreviation. You don't do FFD, things like that. Okay, you don't want to lose a point unnecessary just because you want to write a couple more characters. Okay, and that's basically the no case. So you may ask, I have spent all the effort on the no relation part, right? So we have checked all of them. And so this depends on which one you try first. So if you try, this is the first one to try, then you actually have this found out and you don't need to continue. And this part will give you all the points, 100% of the question. However, the previous step I wrote down, they are useful also. For the yes case, you definitely need every single one, right? Remember? Even though for the no case, right? Possible, the first two you checked, the step like I wrote, you did correctly, but the last one, like this one, you made a mistake, then you still have partial credit on whatever you produced in the previous step. So regarding the partial credit, you can only get partial credit if you answer towards answer the question. So for example, the following things will not give you any points. Some students just copy down the second normal form definition to answer the question, 0 point. Okay, some students may just say, no, this is not a second normal form because a non-prime attribute is not fully function dependent on a key. This is 0 point. You need to apply what you know. You need to tell me which non-prime attribute, that's this one, is not fully function dependent on which one. And most likely I want to maybe see this part, and that's actually tell me I don't need the last number here, and it can help me to convince me that you actually know the problem. Okay. Okay, so that's for second normal form. Let's do a pre class exercise. Okay, let's actually do we do this one first. Okay, an easy one first. Relation R have A, B, C, D. Okay, and I have the following functional dependency: A, B, C, D. So from A, B to C and to D, and A to D, D1 after 2. And I also give you the key. In this case, I only have one key, that's AB. Okay, only one key here. And my question is R in second normal form or not, and why? Okay, so how about you work on it, and I will give you the solution next class. Let me see, did I give you everything?